What's going on, everybody, and welcome to a tutorial on facial recognition with the face recognition package. So to get started, you should be able to just do a pip install face recognition, but depending on your operating system and depending on whether or not you want to use CUDA and so forth, there's many different paths that you could take for the installation. So check out the text-based version of this tutorial if pip install face recognition just doesn't do it for you. So with that, what I want to do is basically just do kind of an overview of the package and how to use it. The package itself is actually extremely simple, and there's really like 3 calls you need to make to the package. The rest is just boilerplate kind of stuff that you need to do around the code to make use of it. So to get started, basically I'm going to be working in the following directory. So this is the code that I'm going to be working on. Just as a reminder, never name your code the same thing as the package you're going to be using. So don't call this face recognition.py. Then we're going to have 2 directories. One directory is known faces, and inside of there is more directories. In this case, we just have one, and it's called CentX. Now, each directory in the known faces directory is going to have basically a directory of an identity that you wish to identify. So just as a reminder, face detection is just finding a face, right? In imagery or videos or whatever. Facial recognition is identifying that face. So face recognition goes a step further. It detects a face and then it recognizes that face. It tells you who that person is or whatever. So inside of this directory, CentX, we've got 3 images. None of these images is the greatest in the world, but you can see here we've got this one. This one's kind of goofy because it has, obviously I've got the EEG headset on, but the face itself is actually a pretty good face. And then this one is not very good. The eyes are covered up and all that. So not the greatest images, but kind of, it'll get the job done. So you can do whatever you want. All these images are on the text-based version of this tutorial. You can use my images if you want. But I really encourage you to use your own images. Grab some images online or whatever. Do whatever you intended to do with facial recognition. So those are the known faces that I have, and then there's also a directory of unknown faces. In this case, we don't know the identities, so it's just a bunch of images, both of me and of Daniel, and the idea is to see can we recognize our own face. This one's an interesting one because it is the deep fake of Snowden's face on my face. So anyway, okay, so, oh, and this is also some deep fakes. So this will be very interesting to see which ones it detects or none or what. Anyway, so that's how everything's set up. You've got the face recognition directory that you're going to work in. You've got known faces, identities, and then images of each of those identities. And you've got unknown faces, which is just a bunch of images that might have many faces. So in this case, we only had, yeah, in all these images, there's actually only one person. Although there is, like in this one, there's a face back here, the back of a person's head, another face here, and so on. So, I mean, there can be multiple faces, but most of these just have one face. And I guess this has a lot of faces as well. Anyway, it doesn't have to be all, like the unknown faces don't really need a single identity. But for known faces, these really need to be just one face that is the identity of whoever this directory is. Okay, so once you've got those things set up, feel free to pause it if you need a second to set everything up. Otherwise, we can get started. So let me just move some stuff around. So the first thing we're going to do is we're going to make some imports and then set some constants. So we're going to import face recognition. So that's the package that we intend to use. We're going to import OS, and we're going to import CV2. So you'd also have to pip install, is it python-opencv? I always forget which one it is. Pip install python-opencv. I think it's either opencv- so it must be opencv-python. So pip install opencv-python. That's probably it. Oh, I guess I upgraded. That probably just broke the whole tutorial. My life. Okay, so continuing along. Once we have those things, so yeah, OS to iterate over directories, CV2 to do image tasks. We're going to use CV to draw rectangles and label the images and stuff like that. So now we are going to have a known faces dir, and that will be known faces, and then we will have an unknown faces dir. So unknown faces dir, unknown faces. Then we're going to have a tolerance. Now this is a degree of, I'm trying to think of another word besides tolerance, but the lower the tolerance, the less chance you're going to have for like false positives. So if you set a very, very low tolerance, but you only have like 1 or 2 pictures of the identity, chances are it's never going to make a match. So the default with face recognition is 0.6. If you want to make more matches, but you're willing to risk being incorrect on the match that you make, you can set tolerance to be like 1.0, very high. But if you want to only match if it's like a for sure thing, set the tolerance to be quite low. I have found 0.6 to be pretty good, but as we'll see, we'll probably have issues with that, both missing predictions, and then as we try to lower it, it's quite challenging. Ideally, you would have like 100 images of somebody's face in different lighting conditions and looking up in all directions and stuff like that. But it's actually it's still pretty darn good, even if you have like what I just used here, some pretty crummy images. So okay, so that's tolerance. Again, the higher you go, the more likely you are to make matches, but you're likely to get a lot of false positives. The lower you go, the more likely you are to get, I guess you would call it false negatives, right? So you're going to miss matches. So now we're going to say frame underscore thickness. This will be in pixel values. Basically, we're going to draw a square around the head. How many pixels do you want that to be? That's going to depend on how big of an image are you using. In our case, I'm going to use 3. And then we'll do font thickness. That will also, I'm going to set that to be 2. And then model, I'm going to use CNN, so convolutional neural network. You can also use HOG, which is, I always want to say hierarchical histogram something gradients. Histogram-oriented gradients? I don't know. Something like that. Anyway, it doesn't matter what it stands for. It is like kind of the older way of doing object detection. So you can use either one you want. I suspect HOG is going to run better on the CPU. So if you're only on a CPU, you didn't install the CUDA dlib, then I might suggest that you use HOG instead. That's quite literally HOG. Feel free to tinker with both. CNN will still run on a CPU, it just might be kind of slow. So, okay, so once we've got that, the next thing we're ready to do is start loading in faces. So to do image facial recognition, we need to be able to do kind of 2 things, right? We're going to detect the face, and then for every unknown face that we happen to find, we need something to compare it to. So the first step that we're going to do is load in all of our known faces, so that we have something for the unknown faces to compare to. So we'll come down here and we will just print just some debugging information. Loading known faces. And basically we're going to have 2 lists. We're going to say known faces. These will be the actual encoded faces. You'll know what I'm saying in a minute. And then known names. These will be the names associated with those faces. So as we populate this out, later when we go to compare the unknown faces, we'll see, does the encoded unknown faces match any of the encoded known faces? If so, at what index value did we find one? And then we will just reference the known names list at that exact same index, and that's, boom, the identity. So, so known faces, known names. And now what we want to do is iterate over all the known faces and store that information. So for name in os.list dir known faces dir. So that gives us the name. Now, remember, that was the identity directory. Now we need to iterate over all the images in that directory. So we're going to say for file name in os.list dir, and we will say known faces dir, and then slash name, and this also needs to be a variable. Cool. You also could use os.path.join. I haven't really decided which one I like better, is using like f strings for paths or os.path.join. I mean, it's meant for this, but os.path.join came before we could do really nice f strings like this, so I find this to be quite legible. So anyway, if anybody knows a good reason why not to use f strings for paths, let me know. Okay, so once we load in that file name, we want to, So for file name, we're going to say image equals, so this is the first call that's a unique face recognition call. Face recognition dot face underscore encodings. And we want to do this for the actual image that we bring in, and we haven't brought in the image. So actually, what we want to say is, so really this will be our encoding. The image is going to be face recognition dot load image file, and then here, here's where we're going to do. We'll do another f string. Known faces dir, name, and then the file name. So then we load the image with facial recognition, we encode that image, and then we are going to add these to our list. So we're going to say known faces dot append the encoding, and then known names dot append the name. Cool. Okay, so now that we've got that, oh, and also when we do face encodings, this is going to encode all of the faces that it finds. So what we actually want to do is we're going to say the encoding will be at the 0th index. So we only want the first face it finds. So again, your identity images, so these ones here, really ought to just have one face, and it should be your identity, right? So you should only have one face in these images, and each of those faces really needs to be the identity here. I mean, this should be pretty obvious, but in case that's not obvious, there you go. So so when we encode the images, it's going to find all of the faces. Unless you specify otherwise, which I'll show you in a little bit. So we're going to say at the index 0. That's the face that we're interested in. So, okay, cool. So now what we want to do is, so we've got the known faces so we can compare to them. Now what we want to do is we want to iterate over all of the unknown images, find all of the faces, and then for each face, compare that face to each of the known faces. So, okay, lots of looping about to occur. So now what we're going to say is print process unknown faces. And cool. So what we're going to do is we need to iterate over first the unknown faces directory. So for file name in os.list dir unknown faces dir. And again, we don't have identities, so we don't need to iterate over those directories, but instead what we're going to say is print, I swear I hit the caps lock, print file name, just so we know where we are. Now what we want to do is load in that file name. So we're going to say image equals face recognition dot load image file, and we want to load in that path. So again, f string, we're going to say unknown faces dir slash file name. Whoops, don't forget this. File name. Cool. So we're loading in that file. So we've got the image. Now what we want to do is we want to actually find all of the faces inside of that image. Now, this is not something we did before because we're kind of just assuming we already know there's only going to be one image and so on. But in this case, we're going to say locations, and what this is going to do is do face detection for us, find all of the locations for faces, and it's just going to find the coordinates. So we're going to say locations equals, and that's going to be face recognition dot face underscore locations, and it's going to look for those locations in the image, and then the model that we're going to use is going to be model. So, okay, so, cool. So now that we have all of the locations that we have, we're ready to make the encodings. So encodings will be equal to face recognition dot face encodings, and we will do this for image and the locations. So we're going to actually specify where are these locations that we wish to encode. And again, we didn't do the locations thing up here for the known faces because it's irrelevant. We don't care where the known faces are in their respective images. It's just not important. But we definitely care where the unknown faces are so that later we can go in and label them. So, okay. So, encodings. Okay. So once we've done that, we are ready to start drawing. Well, we're going to iterate and try to make matches, but we want to be able to draw on the image. So first we're going to convert this image so we can use it with OpenCV. So we're going to say image equals cv2 dot, and what we're looking for is convert color. Yes, convert color. And we are going to do this on the image, and then we're going to do cv2 dot color rg. Let's see, rg. Shoot, what are we looking for? I think we're looking for RGB to BGR. So color underscore, yeah, RGB to BGR. Cool. So also, just as a side note, this video is sponsored in part by Kite, which is a autocomplete engine for Python. By far the best autocomplete engine. Both it's learning as you're typing things here to like kind of give you suggestions on your autocomplete. It also has like snippets for like functions, especially like really well-known functions. Like when I'm working with like TensorFlow and Keras, it's amazing for like when you do like fitments and trainings and stuff like that. It helps you just like write those lines super fast. For something like face recognition, I don't really know that it knows too much about face recognition, but still it's been helping a ton on some of these autocompletes, and at least for me, I hate most autocomplete engines. I think they're just trash. I'm usually like working around the autocomplete rather than getting any benefit at all from it. So I actually really like Kite. And then also, just as a side note, as you're coding, if you use this Kite Copilot thing, it's basically like a rolling documentation. So whatever the last thing is that you were working on, you like basically wherever your cursor is, it's just constantly updating with the documentation. So if you kind of forget like what are these things or how do I use this thing or whatever, it's already there. I spend so much time like having to Google like a specific function or like converting the color. I don't have that memorized. I don't have like, I couldn't remember it was like color underscore. I can't remember, you know? So it's just really convenient to have that stuff there. So Kite's like totally free to use, works on pretty much every major editor. I definitely suggest you check it out. I've really been enjoying using it myself anyway. So, okay, continuing along. So now we've got the image. We've converted it to BGR because BGR is what OpenCV thinks is best. I don't know. So, okay, so we've got our image. Now what we're ready to do is iterate over the encodings and locations for the unknown faces that are found. So what we're going to say is, we'll come down one more line, for face underscore encoding, and then face underscore location in zip encodings locations. So for each of those, what we want to do is first we want to see, are there any matches that we can find? So here comes what I believe to be the third and final line of the face recognition package, and the rest of this stuff is just like I said, just code to do all the other things that you want to do. We're going to say results equals face underscore recognition dot compare faces, and then we're going to compare known faces to the face encoding at the moment. So we're basically, this will be the list of known faces that you have. This is the thing that you're trying to compare to. See, are there any matches? And then at what tolerance do you want to use? Again, the default tolerance is 0.6. That's what we're going to go with to start, but I'll show you guys some variances as well. So now what results are going to be is it's going to compare the current encoding to every single face that we know about, and then it's going to return to us a list of booleans. So it's just true or false. And you might have multiple trues, and then or you know, like in our case, we only have one known face. So it's either going to be, hey, are any of these a syntax match, you know? But in the future, you could have many known faces. So just keep that in mind. But this will be a list of booleans going through the known faces. For any boolean that is true, you would want to say, okay, at what index was that true? And then check the known names list. So in the no names list, you're going to have that list of identities. So at the exact same index, you'll have the name for that face encoding that we know about. So what we're going to do in this case is we're just going to say currently match equals none. And then we're going to say if true in results. So as long as we got a single true, we're going to say the match is the known names. And then we're going to grab the index. And basically we're going to say results.index for true. So again, in this case, we're kind of cheating a little bit, but we're just going to get the one single identity here. And then what we'll do is we will say print match found, and then we'll say match. We'll make this an F string. Cool. All right, so cool. So now all we need to do is some OpenCV stuff to like draw the rectangle and say who the match is. Because obviously it's one thing to like find the match, like we can prove that we found a match. But what we're really more interested in is like seeing it on the image. You know, everybody knows that iconic like boxes around the head thing. So yeah, we definitely have to do that. So what we're going to say here is we need to get the coordinates for the match. So we're going to say, and the way that what you're going to do anytime, like we're going to use cv2.rectangle to draw a rectangle like around the face. To draw a rectangle, you just need two things. You need the top left coordinate and the bottom right coordinate, and then it draws the rectangle. So we're going to grab top left, and that is going to be the face location at the 30th. At the index of 3, and then face underscore location at the index of 2, or actually this will be 0. Yeah. And then we'll just copy this top left, then this is bottom right, and then for bottom right, yeah, it's 1 and 2. 1, 2. And then we're going to do color. For now, I'm just going to say color 0, 255, 0, 255, 0. So green. And if you want, you can check out the text-based version of this tutorial for a much more fancy version of dynamically picking a color based on the identity. Maybe in the next video, too, when we do it with like video, we can show that. Because in this case, we're going to run out of time. We're probably already out of time. But we're just going to do it on images, but of course you can do this exact same thing on video because video is just a succession of images. So yeah, we can probably do something on video and then kind of make this a little more advanced. So I've got lots of other things to show you depending on interest here. But anyways, for now we'll just have a static color, but that you can check the text-based version of the tutorial for a function Daniel came up with, which is pretty cool. So now we have our color. Now we want to actually draw the rectangle. So to make a rectangle, it's just cv2.rectangle. Now, again, so CV2, Kite is a little better at CV2. They know a lot of things there. So lots of great suggestions from here. So anyway, image. So we're going to draw the rectangle on the image. We're going to draw it at top left. Did I hit my insert? I have no idea what I've done. Or is this just frozen on me? I think I might have just, yeah. Oof, that's ugly. Oh dear. Just what you want to happen during a tutorial. Oh yeah. I don't really know if I should open Sublime and it'll restore. Okay. Ugh. I think we've survived. Okay. So okay, cv2.rectangle. So top, left, bottom, right. Yes. And then whatever color we decided to use, and then the frame thickness. Now, that'll draw the rectangle, but we also kind of want to label the rectangle. So the next thing that we're going to do is, again, a top left, bottom right. So I'm actually going to copy this, come down here and paste. Now this rectangle is going to be just like at the bottom. So you got a big rectangle, and then we're going to have a smaller rectangle, and this is just going to house the text at the bottom of that rectangle. So in this case, we don't want exactly the same dimension, so it's actually going to be 3, 2, and then we're going to pull it upwards. So we're actually going to say 1, and then at the face 2, we're going to say plus 22 pixels up. Okay, so top left, bottom right, cool. So now we're going to draw that rectangle, and actually, again, I'm going to copy this. I'm going to come down here, paste. So image, top left, bottom right, color, and then rather than frame thickness, it's CV2 dot, is it just filled, maybe? Yeah, filled. See? That's convenient. So, so now we've drawn that rectangle. Now we want to actually, so the rectangle is there. It's filled with green, whatever our color was, or a custom color if you want to use a cool function. Now we're ready to actually put the text there. So we're going to say cv2.put text, yes. Image, what's the text, whatever the match was. And then the location for the text is going to be this like 3, 2, but then we're going to kind of place it in a slightly different location. So at the this coordinate, we're going to say plus 10, and then over here, we're going to say plus 15, just to kind of adjust it somewhere in the middle. Then we're going to specify our font. So the font that we want to use, again, cv2 dot Hershey simplex, that'll be fine. Then we're going to say 0.5 will be the size. Now you can specify the color. In this case, we'll just do like kind of like a barely off white, and then whatever our font thickness was. If you want to make that a multi-line function or multi-line of parameters, feel free. That's quite a long line. Okay. So that puts our text on the image, and now that we've done that, basically what we want to do is we want to, for every unknown image, we want to do this whole block all at once, and then when we're all done, right, for each image, we want to show the image. So I'm going to say cv2 dot, wow, imshow, and we're going to show the file name, and then we're going to the actual image. Did that just freeze again on me? Are you kidding me? Okay, trying that again. Imshow. I need to figure out why is that lagging out on me. Okay, so we imshow. This is the title of the image, just in case you don't know what CV2 is doing. And then this is the actual image that we wish to show. Then we're going to do cv2.wait key 0, so just as soon as we're ready. And then cv2.destroy all window or the window. It really doesn't matter, but if you want to destroy the specific window, you can give the file name. Now, I'm on Ubuntu. And for whatever reason, OpenCV doesn't like Ubuntu very much. And the destroy window won't really work. So my solution is to, so if you're on Windows and maybe Mac, I'm not sure, but I think it's for any Nix type operating system. But anyway, I'm going to comment that out, and I'm actually going to say cv2.wait key 10,000, so it's in milliseconds, so 10 seconds. And if we press a key at any point, we'll continue to the next image. But anyway, it's super messy. I so rarely work with OpenCV on Ubuntu. I work with it, but I don't really display things live, so I haven't really run into this issue very much. But anyway, that'll be a temporary solution to that problem. That's not the directory we want to be in. So let me just open it here. Open in terminal. We'll do Python facerec example.py. So let's see how we've done. So it loads the known faces, boom. Okay, no match here, that's good. I'll press a key, hopefully we'll get it. Great, awesome. I think if we just close it, it'll be no good. So I'll just keep pressing keys for now. Okay, so then here we've got a ton of matches. Syntax did not detect that as syntax, okay, but did clearly detect, put your jokes in the comment section. Clearly detected a definite Snowden faces syntax, that's funny. Okay, no detection there. Detection there, but also detection, like, clearly I'm just a man with glasses to the machine because I got both of those. Okay, fine. Also another deep fake, although this one's a little less far along, so no real surprise there. No detection, that's good, that's good. A pretty challenging detection, and it got that one, that's pretty cool. Another good detection. Okay, so that was all of them, very good. So the only other thing is, okay, so in that one image, like we got a false positive, right? That guy in the background. So the next thing you could do is like, okay, well, let's say we want a lower tolerance, you know, like, I don't know, let's go with 0.3 tolerance. Let's run that again. Nothing, nothing. Wow, none of these, actually. Oof, we're in trouble. I think 0.3 is going to be too low. Oh boy. So we did not get that guy in the background, but as you can see, you set the tolerance too low, you get no matches. So many false negatives here. Really, not a single match. Not a single match. Okay, let's try 0.5. Let's just go slightly different than the other tolerance. Okay, so that worked out pretty well. I mean, it missed some of these clear examples, but that's okay. Got that one. Did not get that one, which is actually correct. But missed that one. I do think that's a hard one. Got that one, though. Cool. Okay, so you can see that you can kind of play with it. And I will say, if you had more faces, more examples, you're going to be even more accurate. You can keep your tolerance kind of high. You're going to get much less false negatives. So yeah, feel free to tinker around. Like I said, you can do this not only on images, but also video. Frame rate is going to vary significantly depending on what kind of machine you're running it on. If there's enough interest, I will follow up this video with another video doing this with video, and then hopefully adding something a little more unique and interesting to that. And we'll see if I end up doing it. But if you have questions, comments, concerns, whatever, feel free to leave those below. Otherwise, I will see you guys in another video.